All right. Day 2, transformations. Welcome back, Math Minions, Pre-Cal peeps. Yesterday, we took a look at transformations of functions. Okay, and you worked on that in class today, hopefully. But we were describing the transformation. So I gave you a function, and I gave you a second function to compare so that you could describe what transformations were going to take place. So we took a function like f of x equals x squared, looked at some different changes to it, and we wrote down the transformations. Remember that we were basing our transformations on whether the changes are happening inside or outside. Inside changes are always horizontal, outside changes are always vertical. Okay, and we said that a shifting happens when you add or subtract, a reflecting happens when you multiply by a negative, and a stretch or a shrink happens when you multiply by some number. Okay, so remembering that always that inside changes are going to have to, we describe them as opposite of what we think, because they are changing an x, but it's a y equals equation. So let's go the other way today. Okay, today we are going to be given an original function and a description of some changes, and we are going to have to write the new equation. Okay, so let me give you an example of that. Again, hopefully you're taking notes, you're putting this into your notes. Pause the video as you need to, and I would suggest that as you do some of this, read it and see if you can come up with the correct answer before I do. Okay, pause it and see if you get the right answer. So here's a new function. Okay, write the new function if f of x equals absolute value of x is reflected across the x-axis, shifted right 3 units, and down 5 units. So we need to write a new f of x, a new function that has all of that. Okay, so let's look at what they want us to do. Okay, they want us to first reflect across the x-axis. Remember, our x-axis goes horizontal, so a reflecting across the x-axis is some type of vertical reflection. Okay, a vertical reflection. Well, how do I get that to happen? Well, if you remember, a vertical reflection is a multiplying by a negative, and since it's vertical, it has to happen outside. So we're going to start off with a negative, and then we're going to have our absolute value bars with an x in it. And then I'm going to continue. I want to shift it to the right 3 units. Well, how do I get it shift to the right? Left and right is a horizontal shift. Okay, horizontal changes have to happen inside the function, and right is minus. Okay, so I get to close off that. Using absolute value bars is like using grouping symbols or parentheses, so this counts as being inside the original function. Okay, and then the next thing I want to do is down 5 units. Okay, down is vertical, so that has to happen outside. If we want to shift it down, we're going to have to put minus 5. So let's go double check everything. Reflect across the x-axis, put a negative out front. Okay, is that true? When I reflect it across the x-axis, let's go look back over here. Okay, reflect across the x-axis, put a negative out front. Okay, shift it to the right is the next thing. Right 3 units. Well, we've got minus 3 in here inside of our function. Let's go look. Right 3, we want to shift it to the right, put it inside the parentheses, but in this case the absolute value bars are acting like parentheses, so we're good. And then the last thing was up 5, so down 5, so there's our minus that has to happen at the end outside. Okay, so our equation now looks like this. Okay, let's try some other ones. This is really all we're going to end up doing. I'm just going to do quite a few different examples here. So again, pause it as you need to write stuff down, but let's go to the next one. Okay, ignore that for now. We'll maybe hit it in a minute. Okay, f of x equals 1 over x is our original one. We want to reflect it across the y-axis, vertical stretch by a factor of 2, and shift it left 7. Okay, now inside, in this case, the inside is going to mean underneath the fraction bar. That's what we're going to count it as being inside. Okay, so if I'm going to take this f of x, this original f of x, and I want to reflect it across the y-axis. Okay, think about it. Again, our y-axis is vertical, so reflecting it across a y-axis is going to be some type of horizontal change. If I want to reflect across the y-axis, then I need to put a negative only on the x. Okay, not out front, only on the x. Okay, Vertical stretch by a factor of 2. Well, how do I do a vertical stretch? Vertical means it has to be an outside change. So I'm going to need to put a times 2 on the outside. Okay? And then left 7. Well, left is horizontal. Horizontal has to happen inside, so we're going to put minus 7 inside. But again, inside needs to be underneath that fraction bar. That's what's going to count as inside. Don't put it out here, because then that would mean down 7. Okay? So this is what we're looking for. Now, if technically I could write it as 2 over negative x minus 7. It's the same thing. But if you got that, you're good to go. Okay? Reflect across the y. That's horizontal, so it has to happen inside only to the x. Vertical stretch, well, it's vertical, it has to happen outside, and a stretch is always a multiplying. Okay? And the left 7, left is horizontal, so it has to happen inside. It's got to be underneath. Okay? Let's do the next one. Now I'm going to start off with x to the third power. Now I want to do a horizontal shrink by a factor of 1/4. Again, let's think about it. Horizontal is going to have to mean inside. Okay? This time, there's no fraction bar to separate inside, so I do need parentheses with a cube on it. Okay? That's how I'm going to know inside. Horizontal has to change only the x. So in order to change only the x, I've got to have parentheses with the cube on it, like that. Horizontal shrink by a factor of 1/4. Okay? Horizontal has to happen inside. And remember, things that happen inside have to be opposite of what we think. So instead of putting a 1/4, I'm actually just going to put a 4 and then an x. Okay? Just because it's horizontal, it's opposite of what I think. Okay? How about right 2? Where does that go? Right is horizontal. So that has to go in inside. Remember, right is minus. Okay? Let me go back and fix this one because somebody should have fixed it by now. This should be a plus because it's at left. My fault. My apologies. Right is minus, left is plus. Okay? Fix that in your head. My fault. I'm sorry. I was wrong. I'm fixing it now. Okay? Right is minus, left is plus. Let's say it again. Right is minus, left is plus. Okay? And then up has to happen outside because it's vertical, so plus 2 at the end. That's what we should be looking at. Okay? We're just going to get better by doing more of these, so let's do a few more. Okay? All right, here's another one that's got a square on it. So I'm going to start it off as f of x. So f of x equals, it's an x squared, so let's see, right 2. How do I get it to go right 2? Where do I put that change? If it's right, it goes inside, so parentheses with a square outside. Vertical stretch by a factor of 3. Vertical stretch. Where do vertical changes go? Vertical changes go outside. Again, horizontal inside, vertical outside, alphabetically. Horizontal goes inside, vertical goes outside. Okay? Vertical stretch. Put it outside. And if it's outside, it is what it is. Inside changes are opposite of what we think. Outside changes are what, it is what it is. Okay? That's what that should look like. Okay, let's revisit this guy again. Let's see if you got it. Okay, up 3. How do I get to go up 3? Well, I'm going to have that 1 over x. I'm going to put a plus 3 at the end. Okay, left 2. All right, let's fix it. Mr. Watt, you just got another chance to fix yourself. Left is plus, and it should happen inside. So for this particular one, no need for parentheses because the division bar is a natural separator. Okay, the division bar is a natural grouping symbol, so we're just going to put a plus 2 underneath. Okay, and now how do I get to reflect across the y-axis? Again, just like last time, put the negative on the x. Okay, horizontal reflection means a negative only goes on the x. Okay, couple more, and then we'll see if we can call it a day. All right, now I have a square root. Natural grouping symbol again. Okay, so I'm going to have my square root. Reflect across the x-axis. Okay, x-axis is a horizontal axis, so reflecting across it is going to be some type of vertical. Negative goes out front because it's a reflect. Reflects always mean multiplied by negative, has to go out front. Okay, Horizontal shrink. Okay, horizontal has to happen inside, and since it's opposite of what we think, we're going to put a 2x. And then down 5. Down 5 is always an outside, minus 5. Okay, how are we doing? Is it making sense, or are you getting stuck and lost and confused? All right, let's try a few more. How about this one? Take a minute and see if you can do it yourself. Pause the video, see what you come up with. Reflect across the y-axis. Again, y-axis is vertical, so horizontal reflection means inside, make it negative. Vertical stretch. Where do vertical stuff happen? Vertical stuff happens outside, so it is what it is, times 2. Left 5. Did we fix that yet? Left is plus inside. No need for parentheses because the square root symbol is a natural grouping. Okay? These are the kinds of things you're going to have to do in the assignment today. So again, we got to be able to go both directions. I got to be able to describe the transformations from an equation. I need you to be able to do that. Here's 2 equations. You tell me what changes are happening, and I need you to be able to write a new equation if I tell you what changes that need to occur. Okay? Again, the bottom line is inside changes are horizontal, outside changes are vertical. If you want to shift, you're going to add or subtract. If you're going to reflect, you're going to multiply by a negative. And if you're going to stretch or shrink, you multiply by some number. Always remembering that stuff that happens inside is opposite of what you think. All right, come to class with questions.